The moment the American forces rolled into the shattered streets of a small German town in late 1944, they were met not by the monstrous tanks or roaring artillery they expected, but by a curious, almost comical little vehicle parked half-hidden in a courtyard, the Kübelwagen. At first glance, it seemed insignificant. A small, boxy car with thin tires, a rickety suspension, and an engine barely bigger than a lawnmower. Its 25-horsepower flat-four engine, tucked under a simple rear hatch, seemed incapable of moving more than a ton of metal across cobblestones, let alone traversing the mud-choked battlefields of Europe. Yet for the American mechanics, hardened men accustomed to the roar of Sherman tanks and the growl of jeeps, this tiny vehicle became an object of obsessive curiosity, a puzzle wrapped in steel, and eventually a source of laughter, amazement, and even grudging respect. From the moment they touched it, the Kübelwagen defied all expectations. The metal body, though lightweight, seemed oddly resilient. Dents bounced back, panels resisted rust, and the undercarriage, which any ordinary car would have shredded against wartime terrain, remained remarkably intact. Mechanics swarmed over it like scientists examining an alien artifact. They traced the lines of the suspension, inspected the axle housings, and finally opened the rear hatch to reveal the engine. A tiny, air-cooled flat-four that seemed incapable of even producing motion, let alone carrying men or cargo. They exchanged incredulous glances, muttering jokes about how the Germans could possibly have thought this fragile-looking machine could traverse the treacherous roads of Europe without collapsing into scrap metal. But as one crew chief slid into the driver's seat, twisted the tiny key in the ignition, and pressed the starter, a faint hum filled the courtyard, a sound so unassuming it almost went unnoticed. And then, with a cough, a pop, and a faint roar, the little engine came to life. What followed was a lesson in humility. The mechanics, who had spent years repairing tanks that weighed 30 tons and jeeps that had to climb mountains, suddenly realized that raw horsepower was only one measure of performance. Despite its laughably small engine, the Kübelwagen moved with a surprising amount of authority. It rolled over cobblestones, climbed inclines that seemed impossible for such a lightweight motor, and handled mud better than any of the jeeps they had relied on for months. The Americans laughed, shouted, and even bet on who could make it jump a puddle first. But as they pushed it harder, navigating narrow alleys and dodging rubble, the realization began to sink in. This 25-horsepower engine was not weak. It was brilliantly efficient. It was engineered with precision, simplicity, and cunning, designed to deliver exactly what was needed and nothing more, in a package so lightweight and unassuming that it could go where no conventional vehicle dared. They began taking notes. The flat-four engine, air-cooled and virtually maintenance-free, could run on low-octane fuel, tolerate abuse from unpaved roads, and continue operating under conditions that would have crippled an American Jeep or a British truck. Every component, from the thin tires to the minimalistic suspension, had been optimized for reliability and utility. Mechanics began theorizing how the Germans had achieved this, by stripping away excess weight, simplifying every moving part, and engineering for endurance over raw power. The Kübelwagen seemed to embody an entire philosophy of design. If a vehicle could survive the war's chaos without complicated systems, it would outlast everything else on the battlefield. Soon, the small courtyard became a test track. Mechanics challenged the vehicle with increasing demands, hauling crates, climbing steep embankments, and navigating mud-soaked roads. Each trial revealed more secrets of its design. The engine's torque curve, though modest in absolute horsepower, was perfectly suited to low-speed maneuvering. The gearbox, though simple, offered ratios that maximized efficiency in every condition. And the vehicle's lightweight meant it could cross terrain that would bog down heavier, more powerful machines. Every success added to the mechanic's astonishment, and every failure, minor as it was dissected and understood, teaching lessons about efficiency, engineering, and ingenuity that many of them had never considered in their careers servicing machines built for brute force. As they pushed the Kübelwagen further, the line between amusement and awe blurred. What had started as mockery became admiration. Here was a machine that laughed at its own limitations, defied expectations, and revealed an entirely new way of thinking about mechanical design. The Americans realized that in the pursuit of raw power they had overlooked something critical: balance, efficiency, and the ability to endure in hostile conditions. The 25-horsepower engine, small and unassuming, had become a masterclass in engineering elegance, proving that sometimes less truly was more, and that survival depended not on size or strength, but on ingenuity and adaptability. By nightfall, the courtyard had become a proving ground. Mechanics slept in shifts, taking the little vehicle out under dim lanterns, testing its endurance, and cataloging every observation. The laughter persisted, but beneath it lay a profound respect, a recognition that the Germans had engineered a machine capable of performing miracles with minimal resources. They realized that this tiny engine was not just a piece of hardware, but a symbol of practical genius, a testament to thinking differently, and a challenge to everything they thought they knew about vehicles in war. And so, as the sun set and shadows stretched across the ruined town, the American mechanics, hardened by tanks, jeeps, and artillery, finally understood the Kübelwagen's secret. It wasn't about horsepower, torque or brute force. It was about precision, balance, and efficiency, a philosophy hidden inside a 25-horsepower engine that could conquer mud, rubble, and ruin with grace. They had laughed at it, mocked it, and almost dismissed it. But by the end of that first day, the little car had taught them a lesson they would never forget. In engineering, as in war, the smallest things often hold the greatest power. From that moment forward, every test, every laugh, and every awe-filled observation laid the foundation for a deeper understanding of mechanical genius. An understanding that would unfold across Europe, behind every vehicle and in every interaction between man, machine, and the chaos of wartime innovation. The tiny engine, overlooked by most, became a silent teacher, whispering lessons about ingenuity, efficiency, and resilience. Lessons that would echo far beyond that shattered courtyard, shaping the way American mechanics, engineers, and pilots approached machines for decades to come. The morning after their first bewildering encounters with the Kübelwagen, the American mechanics were brimming with curiosity, excitement, and a hint of mischief. The tiny vehicle had already proved far more capable than anyone expected, but instinct told them that its secrets ran deeper. If it could navigate rubble-strewn streets and mud-choked alleys with ease, then what else could it endure? They resolved to find out. That day, the ruined town's courtyard transformed into a full-scale testing ground, a proving arena where each mechanic would push the 25-horsepower engine, the lightweight suspension, and the fragile-looking chassis to limits that no designer, no manual, and certainly no German wartime planner had anticipated. Every stone, every ditch, every incline became part of the experiment, and every test carried a palpable mixture of fear, exhilaration, and awe. The first test was simple: climb a steep embankment that a Jeep barely managed on a dry day. The mechanics lined up, watched, and whispered as one climbed into the driver's seat. With a cough and sputter, the little flat four roared into life. The wheels spun, the suspension flexed, and slowly, almost imperceptibly at first, the tiny car began its ascent. The men cheered, then fell silent, watching the vehicle tackle the incline with a combination of grace and stubborn determination that defied every expectation. The engine strained, temperatures rose, and the exhaust gave off clouds of smoke that would have terrified any ordinary mechanic. Yet it held together, powering forward with the precision of a Swiss watch. That moment marked a profound revelation. The Kübelwagen was designed not just to survive, but to thrive under conditions that would destroy conventional vehicles. Encouraged, they pushed further. Mud pits became trials of traction, testing the tires and suspension as the vehicle slipped, slid, and somehow clawed its way through thick sludge. Every attempt to stall the engine, to overwhelm its limited horsepower, failed. It adapted. The flat four seemed to work harder the more it was challenged, delivering torque precisely when needed and maintaining momentum where heavier, more powerful engines would have bogged down and sputtered. Mechanics laughed, shouted and scribbled notes furiously. They began to treat the car like a laboratory, taking meticulous observations about fuel mixture, throttle response, and even tire wear, documenting every subtle nuance as though they were discovering a new element. Next came the endurance trials. The men rigged makeshift obstacle courses punctuated by debris, rubble, and abandoned fortifications. They demanded sudden starts and stops, sharp turns, and repeated accelerations, mimicking the stresses a combat vehicle might face. The engine whined, tires spun, and metal flexed, but the Kübelwagen endured. Every trial revealed another lesson in German efficiency. The lightweight frame minimized energy loss. The simple drivetrain reduced friction and potential failure points, and the air-cooled engine tolerated overheating in a way American mechanics had never imagined possible. They marveled at the genius hidden inside its modest 25 horsepower, realizing that while brute power won battles for other machines, here, elegant engineering conquered all obstacles. They even began experimenting with improvisation. Mechanics loaded the vehicle with extra cargo, testing how the tiny engine handled weight beyond its rated capacity. They drove it across uneven streets with hidden potholes, deliberately steering into situations that would destroy a standard Jeep. Each time, the Kübelwagen responded not with failure, but with a mechanical intelligence that seemed almost intentional, a design so finely tuned that every component worked in harmony to survive abuse. They were discovering lessons in balance, torque distribution, and stress management that would have taken months of laboratory research. But here, in the field, every discovery was immediate, visceral, and impossible to ignore. The more they pushed, the more the mechanics understood the philosophy behind the design. The Germans had not aimed for raw power or flashy specifications. They had aimed for endurance, adaptability, and simplicity, a machine that could perform reliably with minimal maintenance, even in the harshest conditions. It was a revelation. In a war defined by firepower and brute force, the quiet efficiency of the Kübelwagen offered a different kind of superiority. Its tiny engine wasn't a limitation. It was the key to its brilliance. And for the American mechanics, hardened by years of maintaining heavy vehicles, this realization was almost humbling. By late afternoon, the testing escalated into what one mechanic later called controlled chaos. They raced the vehicle across uneven terrain, through streams, and over obstacles improvised from fallen beams and rubble. They measured fuel consumption, recorded engine heat, and even observed how the suspension reacted under different loads. Each test produced data, insight, and a growing sense of awe. They began to understand that every design choice, from the flat-four engine to the lightweight body, was intentional, a product of precise engineering and battlefield experience. And in that understanding, they discovered something more profound. Ingenuity could outmatch raw power, and efficiency could triumph where brute strength would fail. As dusk fell, the mechanics gathered to reflect on the day. The tiny Kübelwagen had survived trials that would have destroyed conventional vehicles. Its engine, long thought laughably weak, had proven its resilience time and again, and the men realized that what they had been mocking as a toy was, in fact, a masterpiece of engineering, a testament to the genius of designing for endurance, simplicity, and reliability under extreme conditions. It wasn't just a car. It was a teacher, a challenge, and an inspiration. The lessons learned that day would echo in their work for years to come, shaping how American mechanics approached vehicle maintenance, engineering, and even battlefield innovation. By the time night fully settled over the ruined town, the courtyard had become more than a testing ground. It had become a laboratory of discovery, laughter, and revelation. The mechanics, exhausted but exhilarated, knew that the tiny 25-horsepower engine had shown them something they could never unsee. That resilience, efficiency, and intelligent design could make even the smallest, weakest-looking machine a force to be reckoned with. And as they secured the vehicle for the night, they whispered among themselves a truth that would stay with them forever. Sometimes, the smallest engines teach the largest lessons. By the third day of testing, the American mechanics had progressed beyond sheer amusement and basic endurance trials. The Kübelwagen, which had initially seemed like a quaint, underpowered curiosity, had now revealed itself as a vehicle of almost inexplicable engineering. They gathered in the courtyard, sleeves rolled, oil-stained hands probing every seam, panel, and bolt. Each inspection uncovered a new layer of ingenuity hidden within its modest frame. From the air-cooled flat-4 engine, tucked neatly in the rear, to the deceptively simple suspension that allowed the little car to traverse obstacles that would have crushed ordinary military jeeps. It was as though the Germans had engineered a vehicle not for speed or power, but for adaptability and resilience, crafting a machine that could survive where others would fail. The first revelation came from the suspension. Unlike the solid axle setups that Americans were accustomed to on Jeeps and half-tracks, the Kübelwagen suspension relied on a torsion bar system that allowed each wheel to respond independently to irregular terrain. Mechanics watched in awe as the tiny car glided over rubble, tree roots, and hidden trenches. Unlike heavier vehicles that bounced, fish-tailed, or ground to a halt, the Kübelwagen absorbed shocks with astonishing efficiency, keeping the tires in contact with the ground and preserving forward momentum. This simple yet brilliant design translated the vehicle's limited horsepower into real-world effectiveness, proving that clever engineering could amplify minimal energy far beyond what raw engine numbers suggested. Next came the drivetrain. The flat-4 engine produced a mere 25 horsepower, yet the vehicle moved with surprising authority. Mechanics traced the gearbox, transmission, and differential, trying to reconcile the apparent mismatch between engine size and performance. They discovered low-friction gears, meticulously aligned shafts, and lightweight, yet strong drive components that ensured power was transmitted with minimal loss. Every element of the drivetrain had been optimized for efficiency and reliability, allowing the Kübelwagen to maintain speed and torque even on inclines, in mud, and under load. Mechanics marveled at the elegance of the system. The Germans had accomplished more with less, creating a vehicle that leveraged intelligence rather than brute force. Fuel efficiency was another revelation. While American vehicles of comparable size consumed large quantities of gasoline, the Kübelwagen ran cleanly and economically on low-octane fuel. Mechanics observed that the air-cooled engine's flat-4 layout allowed consistent cooling without heavy radiators or water pumps, which often failed under combat stress. This meant the little vehicle could operate in environments where others would overheat or stall. Every drop of fuel was used judiciously, a principle that the Americans had never fully appreciated in wartime vehicles. It was not just a car, it was a lesson in resource optimization and battlefield practicality. The rear engine layout also contributed to performance in ways that were initially counterintuitive. Mechanics noted that the weight over the drive wheels enhanced traction on loose terrain, while the simple cooling system reduced maintenance needs and the risk of catastrophic engine failure. Every component was interdependent, forming a coherent system in which the car's limitations became advantages. As the mechanics explored further, they discovered the ingenuity of component placement, the precision of torque distribution, and even the way the vehicle's lightweight body reduced stress on tires and axles. The Kübelwagen seemed almost alive, as if every element had been meticulously designed to anticipate the demands of a war-torn environment. The American mechanics also began experiments to stress-test the vehicle further, deliberately loading it with cargo and forcing it over obstacles that would have crippled a conventional military vehicle. Every trial revealed additional insights. The tires, though narrow and modest, maintained contact and absorbed shocks. The suspension flexed without bending permanently, and the engine, small as it was, responded with surprising resilience. Mechanics began to take detailed notes, sketching diagrams, recording torque, acceleration, and wheel articulation, amazed that such simplicity could achieve such remarkable real-world performance. It became clear that the Germans had prioritized reliability, efficiency, and adaptability over specifications like horsepower, displacement, or top speed, principles the Americans would later recognize as essential for modern vehicle engineering. Even the tiny details were instructive. The engine mountings minimized vibration and stress on the frame. The carburetors were simple, yet responsive, and the exhaust routing reduced heat buildup without unnecessary complexity. Mechanics who had spent years maintaining large, powerful vehicles suddenly saw the elegance of lightweight, minimalist design. Laughter and disbelief mixed with awe as they realized the extent to which the Kübelwagen's genius lay in its ability to combine simplicity with effectiveness. A 25-horsepower engine, clever weight distribution, and minimalist construction had produced a vehicle that could outperform expectations repeatedly. By the end of the day, the American mechanics were exhausted, covered in grease and dust but profoundly enlightened. What they had initially mocked as a tiny, underpowered vehicle had revealed itself to be a masterclass in engineering ingenuity. Every part, every bolt, every centimeter of the chassis was optimized for maximum utility with minimum resources. The lessons they took away: efficiency, durability, intelligent weight distribution, and reliability under stress would influence their work long after the war, shaping maintenance practices, vehicle design philosophy, and the understanding that less could indeed be more. As night fell and the Kübelwagen sat quietly under a lantern-lit sky, it no longer seemed like a mere vehicle. It had become a teacher, a silent instructor in the courtyard, revealing truths about engineering, resilience, and the power of clever design over brute force. For the American mechanics, what began as curiosity had turned into a revelation. The 25-horsepower engine, far from being a limitation, was the heart of a vehicle that could endure, adapt, and triumph where larger, stronger machines would falter. Every trial, every observation, and every laugh had cemented a single truth: engineering brilliance does not always roar. Sometimes it whispers quietly in the hum of a tiny engine that refuses to fail. By the fourth day, the American mechanics had moved beyond curiosity and cautious testing. The Kübelwagen, which had first been treated as a quaint novelty, had become the center of an experimental proving ground. The courtyard was transformed into a battlefield simulation, strewn with rubble, mud, and improvised obstacles. Mechanics, fueled by coffee, adrenaline, and the thrill of discovery, were determined to see just how far this tiny 25-horsepower engine could be pushed. Every trial was designed to challenge not just the limits of the vehicle, but the assumptions the men carried about what engineering could achieve with minimal resources. They wanted to see the Kübelwagen fail, but time and again, it refused. The first extreme test involved an artificial incline created by stacked rubble and beams, simulating a steep embankment that a full-sized military truck would struggle to climb. Mechanics watched, holding their breath as the tiny car approached. The engine whined in protest, the tires spun briefly, but the Kübelwagen crept upward with astonishing precision. The rear engine weight distribution provided unexpected traction, while the torsion bar suspension absorbed each irregularity without destabilizing the vehicle. Mechanics shouted, laughed, and even bet on whether it could reach the top without stalling. The vehicle, seemingly aware of the challenge, pressed on and conquered the incline, leaving the mechanics in a mixture of disbelief and exhilaration. Next came water crossings. They built a shallow trench filled with mud and debris to mimic flooded terrain. American vehicles, even with higher horsepower, often struggled in similar conditions, yet the Kübelwagen handled the challenge with grace. The air-cooled engine kept running despite mud splashing across the rear compartment, and the low-friction drivetrain transmitted power efficiently, preventing the wheels from digging in and stalling. Mechanics documented the results with meticulous notes, realizing that every design choice, from tire composition to engine placement, had been carefully considered to maximize performance under such conditions. The laughter that accompanied the trials became tinged with respect, as it was impossible to ignore the ingenuity at work in such a seemingly simple machine. The mechanics then subjected the Kübelwagen to repeated acceleration and deceleration trials on uneven terrain, forcing it to stop and start on loose gravel, cobblestones, and makeshift ramps. Each time, the engine responded with remarkable consistency. The tiny flat-four, producing only 25 horsepower, delivered torque exactly when needed, while the lightweight body allowed the vehicle to maintain momentum even in treacherous conditions. Mechanics marveled at the balance between simplicity and functionality, noting that every ounce of energy from the engine was efficiently converted into usable motion. The vehicle seemed to anticipate the demands placed upon it, almost as if it had been designed to survive not just the terrain, but the very intentions of those trying to break it. Load-bearing tests followed. The mechanics stacked crates, ammunition boxes, and improvised weights into the vehicle to simulate battlefield transport. Even under these additional burdens, the Kübelwagen maneuvered as though unencumbered. The suspension flexed without failure, the tires maintained contact with the irregular surface, and the engine continued to deliver consistent power. Each trial revealed insights into the German philosophy of efficiency. By prioritizing durability, weight distribution, and low-maintenance design, they had created a vehicle capable of performing far beyond what its specifications suggested. The mechanics, who had spent years maintaining larger, more powerful vehicles, were awestruck at how effectively this tiny engine translated effort into real-world results. Perhaps the most astonishing trial involved a simulated enemy zone, where the mechanics set up a course filled with rubble, hidden dips, and uneven inclines to mimic the challenges of combat terrain. They drove the vehicle repeatedly, recording every detail: wheel articulation, engine temperature, suspension response, and drivetrain performance. Each test revealed hidden strengths. The torsion bar suspension absorbed impacts that would have damaged conventional vehicles. The lightweight body reduced stress on critical components, and the rear engine design enhanced traction in unpredictable conditions. Mechanics began to whisper to each other in awe, realizing that this seemingly fragile car could have outperformed heavier, more powerful vehicles in the same environment. Even minor observations became lessons in mechanical brilliance. The simplicity of the carburetors allowed them to function reliably in harsh conditions, while the exhaust system minimized heat buildup without complex routing. The placement of every bolt, panel, and rod seemed deliberate, designed to prevent failure even under extreme stress. Mechanics, who had initially mocked the tiny engine, began to see the philosophy behind its design. It was not about raw power, but about resilience, efficiency, and the ability to adapt. Each trial reinforced this understanding, transforming their view of the vehicle from a curiosity to a masterpiece of wartime engineering. By the end of the day, the mechanics had pushed the Kübelwagen to every conceivable limit. They had forced it up inclines, through mud, over rubble, under heavy load, and across uneven terrain. And each time the vehicle had survived, often performing better than expected. Exhausted, exhilarated, and covered in dirt and grease, the mechanics realized they had witnessed something extraordinary. A 25-horsepower engine, combined with intelligent design and minimalistic construction, could outperform expectations in ways that raw horsepower could never achieve. It was a lesson in engineering philosophy, resilience, and innovation, one that would echo through the mechanics' work for decades to come. As night fell, the tiny vehicle rested silently under lantern light, its engine quietly cooling, and the mechanics stood in awe. They had tested its limits, pushed it to extremes, and discovered secrets hidden beneath its modest hood. What began as curiosity had transformed into profound respect. The Kübelwagen was more than a machine. It was a testament to ingenuity, efficiency, and the power of clever engineering over brute force. The lessons learned that day would shape their understanding of mechanics, design, and battlefield adaptability for the rest of their lives, proving once and for all that even the smallest engines could teach the greatest lessons. By the fifth day of trials, the American mechanics' fascination with the Kübelwagen had grown into something bordering on obsession. What had started as a laughable curiosity, a tiny 25-horsepower engine in a compact, almost toy-like frame, had become the centerpiece of a full-scale investigation into German engineering genius. They decided it was time for the ultimate test, direct comparison against the American military vehicles they had been maintaining and relying upon for years: jeeps, half-tracks, and even light tanks. The goal was simple, yet audacious: to see if this miniature car, with its modest engine, could outperform machines many times its size and horsepower in real-world battlefield conditions. The first challenge involved mobility across uneven, debris-littered terrain. Mechanics set up parallel courses for the Kübelwagen and a standard Jeep, mimicking the war-torn streets and rubble-strewn fields they had encountered in Europe. The Jeep, heavier and more powerful, struggled over the debris, bouncing violently on its suspension and sometimes stalling in mud pockets. The Kübelwagen, by contrast, glided over the same obstacles with remarkable composure. Its torsion bar suspension absorbed shocks that would have rattled larger vehicles to a halt, and the rear-engine weight distribution ensured that the tiny tires maintained contact with the uneven surface. The mechanics watched, jaws agape, as the vehicle repeatedly navigated terrain that should have been impossible for such a small engine. Laughter turned into disbelief, and then into grudging respect. The little German car was winning against machines designed for brute force. Fuel efficiency became the next measure of comparison. While the Jeep guzzled gasoline to maintain its performance over the same course, the Kübelwagen consumed far less, completing longer runs without refueling. Mechanics documented every observation, measuring mileage, torque output, and engine temperature. They realized that the Germans had prioritized not just endurance, but economy of operation, a principle often overlooked in American designs that emphasized power over efficiency. This discovery was revelatory. A vehicle that required a fraction of fuel to achieve similar or superior performance represented a logistical advantage that could not be overstated. Especially in war zones where supply lines were stretched thin, handling was the next revelation. Mechanics devised tight turn courses, obstacle dodges, and sudden directional changes to mimic urban combat conditions. American vehicles, despite superior horsepower, exhibited lag, oversteer, or instability, especially under load. The Kübelwagen, nimble and lightweight, responded instantly to the driver's inputs. The flat-4 engine, though small, delivered power precisely where needed, and the vehicle's balance allowed it to navigate tight corners, climb embankments, and recover from slips with astonishing composure. Mechanics began to whisper among themselves, recognizing that what they had once considered a toy might actually be a superior tactical vehicle in certain environments. Even under heavy loads, the Kübelwagen continued to impress. Mechanics stacked ammunition crates, supplies, and personal gear to simulate field conditions. The vehicle carried the extra weight without strain, maintaining traction, balance, and engine performance. The Jeep, in contrast, showed fatigue, struggling over the same terrain and consuming more fuel to maintain speed. Every test revealed a new layer of German ingenuity. Minimalism, efficiency, and intelligent weight distribution allowed the small car to outperform vehicles with engines several times larger. Mechanics, seasoned by years of working with heavy equipment, were forced to reconsider assumptions about what constituted power and performance. The final test of the day was a simulated rapid deployment across mixed terrain, cobblestones, mud, rubble, and shallow water crossings, designed to replicate the unpredictable conditions of a European battlefield. The Kübelwagen navigated each segment with grace, never faltering, never overheating, and maintaining steady acceleration. Its small engine produced just enough power to move efficiently, yet the suspension, lightweight frame, and rear engine design amplified its effectiveness. Mechanics tracked every detail: engine RPM, wheel rotation, suspension flex, and ground clearance, and concluded that this tiny vehicle had demonstrated battlefield superiority in scenarios where raw horsepower alone was insufficient. By sunset, the mechanics convened to debrief. What they had witnessed over the past 5 days challenged everything they thought they knew about military vehicles. A 25-horsepower engine in a tiny car had outperformed heavier, more powerful American machines in multiple measures: mobility, fuel efficiency, handling, and reliability under stress. They laughed at the memory of their initial skepticism, realizing how profoundly wrong they had been. The Kübelwagen had proven that clever design, precision engineering, and a focus on adaptability could triumph over raw size and power, redefining their understanding of what a vehicle could accomplish in wartime conditions. The implications were staggering. Mechanics recognized that such engineering principles could influence American vehicle design, maintenance protocols, and tactical deployment for years to come. They documented every observation, from the efficiency of the flat-4 engine to the resilience of the torsion bar suspension, intending to replicate, adapt, and learn from these insights. What had begun as casual experimentation had transformed into a comprehensive study of efficiency, ingenuity, and battlefield practicality. The Kübelwagen, a vehicle once dismissed as a tiny, underpowered curiosity, had become a blueprint for understanding how simplicity and clever design could outmatch brute force. As night fell over the makeshift proving ground, the American mechanics stood in awe of the little car. They had tested it against their own military vehicles, pushed it to extremes, and discovered a level of engineering brilliance that transcended horsepower ratings and technical specifications. The 25-horsepower engine, combined with intelligent weight distribution, simple yet effective suspension, and minimalistic design, had demonstrated a truth that was both humbling and exhilarating. In engineering, as in war, effectiveness often comes not from overwhelming power, but from clever design, adaptability, and efficiency. The lessons they had learned that day would resonate for decades, shaping their approach to vehicles, machinery, and innovation long after the war had ended. As the final day of experimentation dawned, the American mechanics approached the Kübelwagen with a mixture of reverence and anticipation. What had started as a simple curiosity, a captured vehicle with a laughably small 25-horsepower engine, had grown into a comprehensive study of innovation, ingenuity, and battlefield pragmatism. Every trial, every obstacle, every stress test had revealed new secrets, culminating in a profound understanding. This tiny German vehicle was more than a car. It was a masterclass in engineering philosophy. The courtyard, once cluttered with debris, crates, and improvised ramps, had become hallowed ground for discovery, where lessons in efficiency, balance, and adaptability had been learned firsthand. The mechanics began the day by revisiting all previous tests, pushing the vehicle beyond anything they had attempted before. Mud-choked ditches, steep embankments, rubble-strewn streets, and improvised water crossings became arenas for extreme trials. They loaded the vehicle with maximum cargo, forcing the suspension, tires, and engine to their limits. Each maneuver revealed hidden layers of genius. The torsion bar suspension flexed without permanent deformation. The flat-4 engine maintained consistent power output under strain, and the lightweight body absorbed shocks without compromising structural integrity. Mechanics marveled at how a machine with such a modest engine could exhibit resilience and capability far beyond its specifications, defying conventional assumptions about horsepower, torque, and vehicle performance. Next came the ultimate mobility test, a long, continuous run across simulated battlefield terrain that combined all previous obstacles into a single grueling course. American vehicles, many times more powerful, had struggled on portions of the course, stalling in mud, bouncing violently over rubble, or overheating under sustained stress. The Kübelwagen, by contrast, moved steadily, predictably, and without complaint. Its engine, producing only 25 horsepower, delivered torque exactly when needed. The rear engine placement enhanced traction, and the vehicle's balance allowed it to absorb every irregularity without faltering. Mechanics who had worked for years on larger machines were forced to reconcile a staggering truth. Intelligent design, efficiency, and adaptability could outperform raw power in practical, real-world conditions. Every discovery reinforced a central lesson. The American mechanics realized that the Germans had optimized every aspect of the vehicle for reliability and endurance. The air-cooled engine required minimal maintenance and could operate on low-octane fuel, while the simple drivetrain minimized energy loss. Every component, from the tires to the suspension to the chassis, was designed to work in harmony, producing a vehicle capable of traversing terrain that would have immobilized larger, more powerful machines. It was a revelation. The Kübelwagen embodied a philosophy that prioritized efficiency, resilience, and intelligent engineering over brute force, and it challenged the mechanics to rethink fundamental assumptions about vehicle design. As the sun began to set, the American mechanics orchestrated a final series of tests designed to push the vehicle to absolute extremes. They navigated inclines that seemed impossible, forced sudden directional changes, and drove through mud and rubble with every ounce of their collective experience. Each trial confirmed the vehicle's brilliance. The engine never faltered, the suspension absorbed shocks perfectly, and the vehicle maintained momentum in conditions that would have defeated conventional designs. Mechanics took meticulous notes, documenting the performance of every component, realizing that this small vehicle offered lessons that would inform American engineering for decades. In the quiet moments that followed, the mechanics reflected on what they had witnessed. They had laughed at the vehicle, doubted its capabilities, and assumed its tiny engine was a limitation. Yet through days of rigorous testing, the Kübelwagen had proved that ingenuity, minimalism, and intelligent design could triumph over size and raw power. The lessons were clear. Efficiency could surpass horsepower, balance could outperform brute force, and simplicity could endure where complexity failed. For these men, the tiny 25-horsepower engine had become a symbol of engineering excellence. A reminder that sometimes the most profound innovations come in the smallest, most unassuming packages. By nightfall, the courtyard was silent. The Kübelwagen, tested, examined, and pushed beyond all expectations, rested under the glow of a single lantern. The mechanics, exhausted and exhilarated, knew they had experienced something extraordinary. They had discovered a machine that embodied the principles of endurance, efficiency, and adaptability, lessons that extended far beyond the battlefield and into the very heart of engineering philosophy. What began as a casual experiment with a captured vehicle had become an unforgettable journey into the genius of design, proving that even a 25-horsepower engine could redefine understanding, inspire respect, and teach lessons that would echo long after the war had ended. And so, as the mechanics finally left the courtyard, the Kübelwagen remained, small, unassuming, yet infinitely powerful in its quiet mastery of engineering. It had laughed at expectations, defied assumptions, and revealed a truth that no American mechanic would ever forget. Sometimes, the smallest engines teach the greatest lessons, and brilliance often comes in the most unexpected forms. The story of that tiny vehicle, its remarkable 25-horsepower heart, and the lessons it imparted would become legend among those who had seen it endure, adapt, and triumph where larger, stronger machines had failed.